Hey guys, you're welcome to this video where we're going to be tackling a LeetCode easy problem labeled squares of a sorted array. So basically the problem gives us an array of numbers and expects us to return the square of each of those numbers in another array, and they must be sorted in non-decreasing or ascending order. So one way we could achieve this is to actually square each of the numbers in the array and just sort them and return that. So that would entail doing returning the sorted of the square of each of the numbers. So doing that using this comprehension for num and nums, but what we want to return is the square of each of the numbers. And yeah, this would do the job nice and easy. But if you're going to be doing this in an interview, ideally, you should come up with, the interviewer will expect an optimal solution, and there are better or more optimal solutions than this. Why? Because this would give us the time complexity of O of n log n because of the sorting. So, I mean, the interviewer could be like, okay, or he could ask you, can you do anything better? Can you have a better produce a more optimal solution, meaning that there's another solution he's seeking for in mind. I mean, if you can't come up with anything at the start, it's good enough to come up with something rather than nothing at all. But we're going to look at how we can optimize this to give us an O of n time complexity instead. So how are we going to achieve this? Let's just have a look at, I'll bring up a whiteboard where I would try to explain what we're going to do. So in here, we have the input array, and this is what we are expecting as a result. So we're going to tackle this using a two-pointer approach. So we'll have a left pointer that will start at the beginning, and we'll have a right pointer that will start at the end. So the reason why ordinarily, if you sort the numbers, they should still maintain their relative position in the array. But because of the presence of negative numbers, and at the end of the day, if you square negative, it will turn to positive. So that will tend to bring some sort of disordering to the sorting of the array. That is why we need to ensure that they are still sorted even after squaring them. Hope that makes sense. So what we're going to be doing, we'll compare the numbers that are marked by the pointers, and whichever one is greatest, we'll put it at the end of the array. Why is that? Because if you see, this number could potentially be big. It could be minus 10, minus 100, minus 1000. But regardless of whatever it is, it will always be at the beginning because of this minus sign. But when we square it, then it could potentially be the largest. It will be contending with this one, which is the largest positive. So that is why when we compare, when we square them, they are now both positive, and at the opposite ends of the array, we then check which is the maximum, and then we put it here. Whichever one is the maximum would be the maximum of all of them. Now, when we have done that, we compare 10 and 60, and 116. So that's 100, and we put it here. And because we've dealt with this, then we advance. R now comes here. We compare again 16 and 9. 16 is greater, so we have dealt with 4. We now come here. L advances. So now L is here, R is here. We compare 1 and 9. 9, of course, is greater, so we move that, and we move R here. We now compare minus 1 and 0. That's 1 and 0. 1 is greater, so we do 1, and then we move R here. And now both of them now collide. At the point of collision, there's nothing else to compare 0 with, so we can just put the last number, the square of the last number here, and that would be our list number. So this will give us an O of n because we're just traversing the list once. It will give us an O of n time complexity. So let's then see how that will be done in code. So we would have the left pointer, which will start at 0 index, right pointer, which will start at the ending index. So that's, sorry, that's the length of nums minus 1. And then we need a result array where we're going to be storing the results. And because the result is going to be the same length as nums, so what we could do is just to have that and just put any number there, and then do it to be the length of nums. So to ensure that it's the same length as the original array. So now we do a loop while left hasn't collided with right. So we want to actually, because we're going to be dealing with, okay, let's proceed and see how this goes. So we have if the number in the left is greater than the number in the right, then we put right at the end of the array. So how do we ensure that we put something at the very end of the array to ensure that we maintain? Because in here, this is already giving us O of n, but we want every operation here to be O of 1. So one thing we could do is to have the index instead, looping over nums or results. So we could instead have for I in range of, we could do length of nums, because what we want to be doing, we want I to start. We want to bring up that. We want to start from here and start filling. We want to start from here and start filling the array. So we want I to start from here, so that when we compare, we put the maximum, we then decrement I would then go here. So we want I to start from the very end. So what we'll do is, since we already captured the very end as right, so we could just put right here, and then we want till we get to 0. Remember that range, the last note here would just be, it wouldn't get to -1, it should just stop at the one before that, which is 0. So we get to 0th index, and then we want to decrement by -1. So what's going to happen here, if nums left is greater than nums right, then we would want to put, we want result I to be equals nums left squared. And then we want to increment that. We could have just gotten the maximum there and put it, but we actually want to know what that maximum is. That's why we started checking, comparing left and right. So we do that. Else just do result I is equals nums right. Now right is greater. Do that, and then we make sure to advance right, and then we just return the result. So I think this should be it. Let's run that now. Wrong answer? What did I do wrong? What did I do wrong? We want the square, if the square. So if the square, my bad. I mean, I could have also used absolute here. If the square of this greater than the square of this. Yeah, so this, yep. So let's run that again. Yep, and then we'll submit that. And that's it. So time complexity, O of n, as explained before, and space complexity. Uh, if we're going to consider the output, then that's O of n. Otherwise, it's just constant space. Because of course, the output has to go somewhere. Consider that O of n. Otherwise, it's constant space. That's O of 1. So you could just tell that to your interviewer like that. And that's it. Thank you.